Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community.
Hello, everyone, and welcome back to another Safeopedia webinar. My name is Samantha, and I'm from Safeopedia, and it is our mission to help you, our EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I want to wish you a good morning, a good afternoon, or a good evening, depending on where you are in the world, and I want to give you a huge thank you for keeping our workplaces safe on a daily basis. Just a reminder, this webinar is being recorded and we will send out a link to you in a few days. We will also have a Q&A at the end of this webinar, so make sure you get your questions and your comments into the Zoom Q&A, and we will get to them at the end of this presentation. Today, we are proud to present Rubber Insulating Gloves 101, Safety, Compliance, and OSHA Requirements. The Safeopedia webinar has been made possible today by Saf-T-Gard, along with PIP Global Safety. Today, our experts, Richard Rivkin and Ben Bird, will explore the fundamentals of rubber insulating gloves, covering safety best practices, compliance obligations, and OSHA ASTM regulatory requirements to help you ensure proper protection and avoid workplace electrical hazards. I am very excited to have you all sit back, relax, and enjoy this presentation. With that, let's jump into it.
Thank you, Samantha. That's about what I was going to start out by saying, was thanking Safeopedia for helping organize and put this on and making it available to Safeopedia subscribers, visitors, and other friends. Welcoming Ben Bird to join me today as we go through rubber insulating gloves. Just a little bit of my background. Saf-T-Gard International is a 90-year-old safety products distributor, personal protective equipment, industrial safety products. We are, rubber gloves go back to our roots. We are members of ASTM, which is the consensus organization responsible for electrical safety standards and technical materials. And it is ASTM standards that OSHA specifically references and enforces. In addition, we are members of IEC, the International Electrotechnical Commission, as well as ISEA, the Industrial Safety Equipment Association. Joining me today is Ben Bird. Ben has 30 years of experience in both electrical and industrial distribution. He leads a team of utility sales representatives around the country that promotes the line of PIP safety products to utilities, electrical cooperatives, municipals, and industrial facilities. He has conducted arc flash awareness training for manufacturing facilities and electrical contractors around the country, and in such, he's very well versed on NFPA 70E electrical standards and OSHA 1910-269 utility standards. As one of 150 PIP safety experts, Ben helps standardize PPE to reduce costs, prevent injuries, and boost productivity. Ben, welcome.
Thank you, Richard. Great introduction. I don't think I need to add anything further.
Okay. Well, then we'll open up with some shocking statistics that it's gonna wake everybody up. Basically, the United States alone generates 4 trillion, I can't even count that high, 4 trillion kilowatt hours of electricity every year. Now, maintaining that infrastructure to generate that much power undoubtedly comes with a high risk of workplace injuries. Industrial buildings require a lot of power for machinery, tools, and systems. And since electricity is common in industrial work, sometimes it's easy to forget the potential dangers of using it. Now, between 2011 and 2023, there was a total of 1,940 workplace fatalities involving electricity. It's not my intention to read everything everybody sees on the screen, but these are some real shocking statistics. This is data from the U.S. Bureau of Labor Statistics and OSHA. So that basically the conclusion there is a need for electrical safety. OSHA rules and NFPA 70E, which governs workplace electrical hazards, require the use of rubber insulating products when even the smallest probability of contact with 50 volts AC or higher exists. Let's repeat that. OSHA rules and the NFPA 70E standards, which is also referenced in OSHA, require the use of rubber insulating products when even the smallest probability of contact with 50 volts AC or higher exists. Basically, that's everywhere. Control of hazardous energy continues to be among OSHA's top 10 violations list every year. But regardless of the heavy fines and serious injuries and deaths that occur from arc flash and electrical incidents, compliance continues to be an issue and a challenge, and that's why we're here. What's even more shocking, pardon the pun, is that many workers are not using rubber insulating equipment because they don't know that they need it or how to take care of it and when to use it. Electrical safety is not only a concern for utility workers or electrical contractors. Almost every single facility has a need for electrical safety, whether the company is a larger facility with building engineers overseeing distribution, or a smaller facility with maintenance staff working on or around floor or wall sockets. Many years ago, it was real simple. If building engineers and maintenance people had to work on equipment, they'd just turn off the power in the plant and go fix it and then turn it back on again. Well, in today's modern industrial age, can't do that anymore. Can't shut down the plant while you're fixing something. So the building engineers and maintenance people are working on energized equipment and distribution within the facility. And certainly at larger facilities, call them steel mills, call them mines, call them refineries, they have their own substations which are bringing in the transmission voltage of 500 kV or higher down to the distribution voltage of 15 kV and then into the plant for 480 distribution. So the electrical safety is there. It's all around. That maintenance staff, janitorial staff, facility staff, equipment operators, they all risk exposure to electrical shock. So education and awareness are critical, not only about the requirements for use, but also about the requirements for in-service inspection and care for continued safety, compliance, and cost savings. It's not just a pair of gloves that you put on the shelf and try to remember when you need them. And sometimes we joke with most seriousness that, hey, the work glove fails, there's the first aid kit, put a Band-Aid on. The rubber glove fails, you die. So just let that sink in for just a minute. While the best way to prevent arc flash and electrical incidents from happening is to de-energize equipment, lockout, tagout. We all know what those four letters LOTO mean. To de-energize equipment before beginning work, as I explained, there are instances where turning off the power could create an even greater hazard. Employers and facility owners must establish safe practices to protect their workers against arc flash and electrical incidents, including the use of PPE, personal protective equipment. NFPA, along with OSHA, mandates and enforces safer electrical work practices under the NFPA 70E standard. Numerous experts and training programs are available to provide guidance on how to keep workers safe and compliant in terms of conducting a proper arc flash hazard analysis. That's step one. Analyze the facility, conduct the arc flash hazard analysis, and then you can determine the PPE category and protective equipment and clothing that are necessary. The results of the analysis will usually guide the property owner regarding the controls that should be in place, engineering, mechanical, human, or otherwise, and review the hazards of both arc flash and electric shock. While there may be some isolated instances where electric shock is not present, in nearly all cases, if there's an arc flash hazard, there's an electric shock hazard because that's what's creating the arc flash. And once that analysis had been gone through, the proper PPE can be determined. One topic that's often not discussed in detail is, as I explained, the need for rubber insulating gloves where that shock hazard exists from exposure to energized equipment. Employees that work on electrically energized circuits and equipment use their hands, making them the most susceptible part of the body to electric shock. Rubber insulating gloves are the only protective gear designed for constant contact with and protection from energized conductors and equipment. All the other items are designed for protection from accidental, incidental, or brush contact. Now, there's a lot of products on the marketplace that claim to offer ARC ratings, but ARC-rated work gloves offer no shock protection. Let me repeat that. ARC-rated work gloves offer no shock protection, and most arc flash hazards have a shock flash hazard as well. There is a very, very slim perimeter where there's no shock hazard, but there might be some arc flash or arc blast. But as I said, over 90+% of the cases, 100% of the cases, that arc is coming from an electrical incident, so that shock hazard is there. ARC-rated work gloves offer no shock protection. Rubber insulating gloves are an essential element in protecting workers that are exposed to high voltage currents. Shock protection is that primary benefit. And today, the rubber insulating gloves and the leather protectors that go with them provide that arc rating as well as the shock protection. Rubber insulating gloves provide significant burn protection as well in the event of an arc flash. So you've got really many layers of protection against that arc flash as well as the shock hazard. Rubber insulating gloves are manufactured using proprietary materials and manufacturing processes with 100% testing to provide the highest level of protection. That's an AQL that's off the charts. 100%, every product after manufacturing is visually inspected and electrically tested before it leaves the manufacturing facility. To be effective, those rubber insulating gloves must incorporate high dielectric and physical strength, along with comfort, flexibility, and durability. Because if they're not comfortable and flexible, workers are not going to wear them, and that's going to increase the risk of injury or death. To help ensure safety and performance, rubber insulating gloves must meet or exceed the requirements of ASTM standard D120, which is the standard specification for rubber insulating gloves and is enumerated specifically by name and number in the OSHA standards. Now, there's a lot of gloves to choose from. So how do you choose the right glove class? According to OSHA 29 CFR 1910-137, rubber insulating gloves must be rated for the voltage to which the worker will be exposed, either phase to ground or phase to phase. Phase to ground is most common in industrial facilities. Phase to phase is in an underground vault or up on a pole where the utility workers are. Those gloves have to be marked to indicate their rating and for their maximum use voltage. For in-service use, that maximum use voltage must be above the actual exposure, but it's important to take note of that proof test voltage as well. All rubber insulating gloves are tested by the manufacturer at the specified proof test voltage. And in just a second, I'll show you a chart that illustrates what the standard of safety and the margin of safety are. Rubber glove manufacturers also perform a dielectric breakdown test at an even higher voltage to validate the dielectric strength of the rubber material and the vulcanization standards that cure that rubber and make it safe to use. The result is a significant margin of safety between the test voltages and the maximum use voltage. Each specified hazard assessment will help in determining which class of rubber insulating gloves is appropriate for the application. So take a look at this. Look at a very common glove. Let's look at the class 0 glove. Those gloves are tested at 5,000 volts AC, but the maximum use voltage is 1,000 volts AC. That's a heck of a margin of safety. The same for if it's a DC test, and we'll talk about DC in a few minutes. Those gloves get a test at 20,000 volts DC with a maximum use voltage of 1,500 volts DC. Take care to choose the correct rubber insulating glove for the task at hand and the level of electrical exposure. Those gloves are all going to have a label on them that is color-coded and identifies the class and the maximum use voltage at AC voltage, which is the most common. Rubber insulating gloves are typically manufactured in sizes 8 through 12, often in half sizes, and some manufacturers offer gloves in sizes as small as size 7 and even as large as size 13. In addition, rubber insulating gloves are available in different cuff lengths of 11, 14, 16, and 18 inches, which vary according to the glove class and the hazard. Rubber insulating gloves are available, as you can see on the chart, in 6 specific voltage classes from 00 through class 4, categorized by the level of voltage protection they offer. They'll also generally indicate if they're a type 1 or type 2 glove, type 1 being normal rubber insulating gloves. Type 2 gloves are rated for their resistance to ozone. That voltage protection is broken down into these classes, and each class of gloves, as I said, is clearly marked with the maximum use voltage, AC, and this is all on that permanent color-coded label. Now, once you've chosen that right glove class, you take care to choose the right size, because proper fit will ensure the likeliness that the workers will wear the gloves. Rubber gloves that are too big or bulky can affect tactile sensitivity, while rubber gloves that are too small can cause discomfort. I'll refer again to ASTM D120, section 8.2, which indicates the measurements on the diameter of the palm for manufacturers, measured at the midpoint of the palm plus or minus a ½ inch, as you can see on the screen. So you measure the hand by wrapping a tape around the palm. This number will generally equate to the probable size of the rubber insulating glove to select. Personal preference for tightness and finger length will ultimately determine the size that the wearer will choose, but it's got to fit right. Now, you got to protect the gloves that protect you, because the rubber insulating gloves do most of the job of protecting against electricity, but they don't protect against the physical hazards of the job. ASTM also references 2 standards for protector gloves. ASTM F496 is a design standard that specifies the construction and type of materials that are used in the design of protector gloves, primarily of leather. The new standard, ASTM F3258, is a specification for protectors that goes beyond the 696 standard and requires arc, cut, and puncture resistance testing and reporting with optional abrasion resistance for testing and reporting. In fact, there are protector gloves available that meet both standards. The OSHA 269 standard that I referred to earlier, that's 29 CFR 1910-269, requires that rubber insulating gloves with protector gloves must be worn by qualified employees within that minimum approach distance to exposed energized conductors. These are the things that are important that are going to save your life and your worker's life. Now, keep in mind there is a tracking and flashover risk, which increases as the voltage potential increases. Since the materials in the protector gloves have no dielectric properties, they protect the rubber protects the electricity. So those materials have no dielectric properties and may occasionally absorb moisture or possibly track electricity. So it is important to maintain a gap between the protector glove and the wearer's body parts, the hand and arm. To do that, the protector glove must be shorter than the rubber glove, so there is an exposed rubber as a line of defense against tracking and flashover. The applicable ASTM specifications refer to the minimum distance between the edge of the protector glove and the cuff edge of the rubber insulating glove. It's a ½ inch for low voltage gloves and 1 inch per glove class for high voltage gloves. So knowing this, for example, the protector glove for a class 2 rubber insulating glove must be at least 2 inches shorter than the rubber glove. As illustrated on the screen, this is a low voltage class 0 glove, so the minimum distance is a ½ inch. This is the protection. Now, besides just designing the products, we have to inspect them before use. And the guide for that is another ASTM specification that is specifically referred to in OSHA, and it's the in-service standard that requires regular inspection of rubber insulating gloves. All gloves must be thoroughly inspected before use. Common problems to look for include cracking and cutting. Prolonged folding or compressing can cause this kind of rubber damage. UV checking. Storing in areas exposed to prolonged sunlight causes UV checking, which also shows up as cracks in the rubber. Oils and petroleum compounds can cause swelling of the rubber. Come on, folks, don't refuel your truck with your rubber gloves on. It's not good practice. Avoid folding them. The strain on the rubber at a folded point is equal to stretching the rubber at twice its length. So don't strain the rubber. And sometimes if there's a snag that gets through that leather protector glove, it can also cause a snag in the rubber insulating glove. Wood, metal splinters, and other sharp objects can snag or tear the rubber. Also, rope burns, deep cuts, and puncture hazards can be causes for rejection as well. This is the glove that's going to save your life. Take care of it. In the qualified inspection facility, rubber inspecting these gloves identifies physical, chemical, or ozone damage. When trained inspectors do this in an inspection facility, direct light is recommended because it enhances the ability to see any surface imperfections in the rubber. Inflating the gloves with air or otherwise stretching the surface helps identify age and ozone damage, as well as any other physical damage, such as snags, rope burns, deep cuts, and punctures. A portable mechanical inflator may be used in the field to enhance the inspection of the glove by simply affixing the glove to the inflator and pumping it up. And then you get to see if there's any damage to the glove that might not be otherwise visible unless viewed after inflating. If that portable inflator is not available, use a rubber glove inspection tool or roll the rubber insulating glove to lightly trap the air inside. So I can show you how this all works. We can take this rubber insulating glove and we put the clothespin type on it. And by rolling it up, it's trapping the air inside so you can see if there's any physical damage to the glove. In addition, if there's been any electrical damage, an electrical failure, by rolling it up, you can see much closer where it's circled that there is a pinhole there, which is from the electrical failure. So this is a real neat tool when that other pump inflator is not available. So let's go back and take a look at some of this again. Expand the rubber insulating glove to no more than 1.5 times its normal size and look for any damage. The use of two-color rubber insulating gloves, such as the one that I just showed, where the inside is a contrasting color, can aid in the identification of problems, because once it's inflated, you can see through to the inner color, and that's an indication that that glove is no longer safe for use. Inspect the protector gloves as well. Dirt and grime can hide damage, and there may be cuts or snags that are causing damage to the protectors and then damage to the underlying rubber insulating gloves. The gloves have to be tested for compliance and saving success. Although damage to many types of PPE can be apparent when the equipment or devices are inspected, rubber insulating gloves are more complicated. The reduction in effectiveness can be caused by a variety of factors that may not be readily apparent, as we showed in some of those earlier physical damage. So take a look at this one. Rubber insulating gloves damaged by abrasions, scratches, cuts, and snags, as well as sunlight, become apparent when they're inflated. The improper use of rubber insulating gloves is a matter of life or death, which is why dielectric testing is a critical and necessary component to maintaining worker safety and compliance. Rubber insulating gloves are expensive, and many times these costs are unnecessarily increased by purchasing replacements that could have remained in service if they were properly inspected, tested, and recertified. Now, you got to know when to test them. As I explained, they're always inspected and tested at the manufacturing facility, but once they're in service, There are periodic retest intervals that are specified in ASTM F496, that standard specification for in-service care. Previously, this standard was subject to interpretation and misunderstanding regarding the maximum test interval for either new rubber insulating gloves or in-service rubber insulating gloves. So the ASTM committee got together and in 2024 updated and simplified the language. What this says now is that the standard clarifies the difference between new gloves and gloves previously put into service and makes it very, very clear that gloves cannot exceed 6 months from the last test or electrically tested within the previous 12 months. 6 months in intervals and 12 months from the previous test if they were put into service and then stored again. Those are the dates. There should never be gloves in service that have more than 6 months from their issue date or 12 months from the last test date, whichever came first. This is clear. Now, gloves that were previously in service within 12 months, they can be stored as required safely and put back into service, but in no case can they be used beyond 12 months from that test date. This is the 2024 update to the ASTM standard. Now, one of the key critical items here is that they're stored properly. So here's the guidance. Gloves will be stored in their natural shape, not wrinkled up, not stuffed in a box. They may be kept inside a dry protective bag, box, or container that was designed for and used exclusively for them. Don't store gloves inside of wet protector gloves. They should not be stored folded, creased, inside out, compressed, or in any way that would cause stretching or compression. So again, the biggest differences in the in-service standard, the most critical change is the clear statement that in no case can a glove or sleeve be used beyond 12 months of the test date. With the addition of this section, the usage window for rubber insulating gloves is now more clearly defined. For example, if gloves are tested on January 1st and stored properly, they can be issued for any time during that calendar year. If issued in March, they can be used for up to 6 months, requiring retesting in September. So again, to make it clear, rubber insulating gloves, whether new or previously issued for service, need to be electrically tested 6 months from the issue date or 12 months from the last test date, whichever comes first. Periodic retesting of rubber insulating gloves should be performed at the proof test voltage that was indicated on that label and on the chart that we showed earlier. This ensures that they're still safe using specialized equipment designed to gradually increase the voltage to that desired test level. This dielectric test is actually twofold. It's pass-fail on the ability to withstand the rated test voltage, and for rubber gloves, it's also quantitative on the ability of the rubber material to minimize electrical current from passing through the rubber gloves above the maximum contained in the specifications. It's a unique machine, and you're welcome to visit us anytime or see some of our videos as to how this works. The rubber insulating gloves are tested by filling them with water and then immersing them with water and applying the test voltage. Once they've passed that inspection and testing process, they're marked to clearly identify the test voltage and the test date, and then can be returned to service. It is somewhat traditional to also mark the date of test or retest so that you know that 6-month or 12-month limit. But this leaves it up to the individual worker to manage that in-service process. For example, if a company has a policy of retesting rubber insulating gloves every 3 months, then in this case, the electrical worker must be aware of when those 3 months have passed since the date of test. In our experience, we recommend a more effective way to manage that in-service time period is for the electrical testing facility to mark the next return for test date according to company policy and within that OSHA mandated ASTM in-service time frame. If you do not have the equipment required to perform these electrical tests, there are independent test facilities that can perform the acceptance test and in-service testing on behalf of end users. At a minimum, ASTM standards require that the inspection and procedure follow this sequence. First of all, they need to be checked in. They need to be demarked to remove any previous test marking. Washing using cleaning agents that will not degrade the rubber insulating properties. Visual inspection of all surfaces inside and out to be sure that there's no physical damage to the rubber gloves. A visual failure is an electrical failure waiting to happen. So we recommend a visual inspection every day before use and then before electrical testing at a qualified test facility. Then there's the electrical testing on that unique equipment that's designed for that purpose. After final testing, there's a final inspection of the product with some necessary record keeping, marking as recommended to indicate the date of test and a return for test date. Careful packing for return shipment in appropriate containers, meaning boxes or similar sturdy packaging materials to prevent folding, creasing, or other loose storage that can cause stress on the rubber for storage or shipment. When selecting a test lab for use, we strongly recommend it is a NAIL accredited test lab. NAIL stands for the National Association of Independent Laboratories for Protective Equipment Testing. You can find more at www.nail4pet.org. NAIL incorporates the only laboratory accreditation for electrical equipment test labs program in North America, and in fact, there is also a NAIL accredited lab in the UK serving Europe. Nail4PET helps develop uniformity in testing and works in close association with ASTM International for developing refining standards that help keep the products safe. Take special care when returning rubber insulating gloves to that electrical testing facility, whether it's your company's own test lab or an independent test lab. Look at that upper right-hand picture. That's from an old post office commercial that says, if it fits, it ships. Forget it. Don't do it. Don't stuff it in to see how you can save a couple bucks on postage and ruin $100 worth of rubber gloves. The ASTM standard on field care inspection and storage also states that rubber insulating gloves shall be stored in their natural shape. Rubber insulating gloves shall not be stored folded, creased, inside out, compressed, or in any manner that will cause stretching or compression. Don't just throw them in a box. After all, these are the products that can save lives. And by the way, don't try to fix them with electrical tape. I've seen it, I don't believe it, but it happens. Proper storage extends the service life of rubber insulating gloves. When not in use, store them in a suitable container, such as a canvas bag specifically designed for this purpose. There are canvas bags on the market now that have separate pockets for the rubber gloves and the leather gloves, which is that reminder every day to remove the protectors from the rubber gloves, store them properly, let them dry out from perspiration or use in inclement weather or other hazards, because at the bottom of that bag is actually a grommet that lets air circulate and let them dry. Never fold them. Folds, creases, strain the rubber and cause it to crack from ozone, as we showed in earlier pictures. Store them with the fingertips up in that right size bag, and don't force more than one pair into a bag. Avoid storing them inside out because that strains the rubber and promotes ozone cutting. It is permissible to store rubber gloves inside of their protectors, but exercise good judgment. If those protector gloves are wet or damp from working in inclement weather or perspiration or any other hazards, remove them from the rubber gloves. Allow them to dry. Remove the protector gloves so that the rubber gloves and protectors can both be inspected before the start of the next workday. And store them in a dry and cool location away from sources of ozone and direct sunlight. That's the way to store them safely. There's also another ASTM specification called F1236 that is a standard guide for visual inspection of protective rubber products. You can see that for additional information. It actually illustrates and explains all the possible damage and hazard that can occur with electrical protective rubber products. Now, with all these different problems to look for when inspecting rubber insulating gloves, coupled with various testing intervals to remember, this can be difficult. There's a lot of steps here to be sure that the rubber gloves that you and your workers are using are safe, and it's easy to see how compliance can fall through the cracks. So consider partnering with an electrical test lab that can test your rubber insulating products and actually manage the rubber insulating products change-out process for you. Keeping these services bundled together under one roof will minimize out-of-service time and unburden you from the coordinating, organizing, inventorying, and scheduling of multiple rubber insulating product types, sizes, and quantities. Yeah, this is a commercial. Saf-T-Gard can manage all of this for you. As a leading manufacturer, distributor, and tester of electrical safety products, now in our 5th decade of electrical safety, as well as our 9th decade of operations, the Saf-T-Gard Voltgard Electrical Safety Division is dedicated to serving industries where worker safety and protection from electrical shock are critically important. Our Voltgard Test Lab is one of the largest independent NAIL-accredited test labs for rubber insulating products in North America. The Voltgard Test Lab performs dielectric testing and recertification for users in every industry for 12 different categories of rubber goods, including gloves and sleeves and blankets and covers and jumpers and footwear and headwear, etc. The Voltgard facility is equipped with state-of-the-art equipment for the testing of these products, including washing, visual inspection, and electrical testing. All rubber protective equipment tested by Voltgard undergoes this rigorous sequence to ensure that your employees are always using safe equipment. Now, electrical testing is not just reserved for AC voltages. I referred to DC testing earlier, and DC testing is also available from Voltgard and other test labs. For maximum safety, it is important to understand the application for use and test the rubber insulating gloves as close as possible to that environment. If you're going to be using them in AC, then test them AC. If you're going to be using them in DC, then test them DC. While AC testing is applicable for general use and most of your in-plant electricity is AC, as well as the electrical service coming into your plant, DC testing is recommended for rubber insulating gloves in applications where it's DC current, and that includes, but not limited to, electric vehicles, both electric and plug-in hybrid, renewable power generation, wind and solar particularly, and electrified mass transit and transportation. As I explained earlier, the ASTM specifications for electrical protective equipment for workers do include both AC and DC test voltages and maximum use voltages for safety. Therefore, it makes sense to DC test rubber insulating gloves where they're going to be used on DC energized circuits and equipment. Okay, another commercial. Saf-T-Gard developed the Voltgard Original Rubber Goods Changeout Program for the industry's first structured, professionally managed program more than 30 years ago in response to customers' needs and compliance with regulatory requirements. The Voltgard Original Rubber Goods Changeout Program provides a hassle-free, start-to-finish solution that monitors, tracks, and manages your rubber insulating products in service use and testing intervals for you, so your workers can focus on other work priorities while staying safe, productive, and compliant. This is ideal for electrical contractors, cable and telecom providers, power and utility contractors, wind, solar energy, public transit, and other large users of rubber insulating products. The Voltgard Rubber Goods Changeout Program includes the listed 5 key elements of cleaning, visual inspection, electrical testing, marking according to your company's safety protocols, and shipment to your warehouse or job site where and when they're needed. Furthermore, Saf-T-Gard has one of the largest rubber insulating products inventories in the world and can immediately replace any goods not meeting applicable standards, including ASTM, OSHA, and your company's own safety policies. No other test lab offers the Voltgard level of service. In addition, Voltgard is proud to offer the PIP range of rubber insulating products in a wide variety of classes, lengths, colors, and sizes. We can meet your needs together, Saf-T-Gard and PIP Global Safety. This is the product line that you can choose from, and we can certainly provide more information for different cuff lengths, cuff styles, classes, etc. The Saf-T-Gard and Voltgard team has more than 100 years of combined safety expertise, focusing on industrial and electrical safety. Our team includes ASTM voting members, OSHA 30-hour trained safety professionals, qualified safety sales professionals, and NFPA 70E trained safety professionals. We join together with PIP, the expertise and experience of our combined teams, to be an extension of your team when you partner with Saf-T-Gard in your company's safety program. So now, Samantha, with your help, we can answer some questions. And one of the first questions that I saw come in was, can rubber insulating gloves be used without protectors? And there are reasons that people want to do this, because protectors do add some bulk. Well, here is the specific language, and I'm going to read it verbatim from that ASTM standard. It says, protector gloves may be omitted for Class O gloves under limited use conditions where small equipment and parts manipulation require unusually good finger dexterity. Under the same conditions, Class 00 gloves may be used without protectors, but only at voltages up to and including 250 volts AC or 375 DC. So basically, without the protector over the rubber glove, you're stepping down what the maximum use voltage could be for either AC or DC. Other classes of gloves may be used without protectors for similar conditions only where the possibility of physical damage to the gloves is unlikely, and provided the voltage class of the glove used is one class above the voltage exposure. So for example, if you're going to use a Class 2 glove without a protector over it, then you're limited to the maximum use voltages for a Class 1 glove. That's one class below. Now, here's a key to using rubber insulating gloves without protectors. Rubber insulating gloves that have been used without protectors shall not be used again with protectors unless given an inspection and electrical retest. Again, rubber insulating gloves that have been used without protectors shall not be used with protectors until given an inspection and electrical retest. And this is to ensure that when they were used without protectors, that there was in fact no physical damage to the rubber that would be covered up or hidden once you put a protector over it. Okay, Samantha, do we have any other questions that came in?
We sure do. Yeah. So one question is, while inspecting, and maybe you covered this before they asked this, but while inspecting, why do we no longer turn the glove inside out when inspecting and testing? I believe that was a practice for many years.
In our test lab, we still do test them inside and out because we have seen damage on the inside of the glove. First of all, sometimes it happens at the manufacturing level, but sometimes on the in-service level, if a worker has a ring or other jewelry on that might have scratched the inner surface or some other hazard that got on the inner surface, we just want to be careful. And it's just a little extra step to ensure that that glove is safe and effective for its intended use, both inside and out.
Okay, good to know. Yeah, they give me a little thumbs up there. The next question, I'm assuming they're doing a month day. So if you're testing on January 1 and they're issued on September 1st, do they still need to be retested the next year on January 1?
No, because if they're issued on, what was that second date?
September 1.
September 1. Okay, they don't have to be issued again on January. Yes, they will have to be issued on January 1 because that's 12 months from the last test date. So you cannot go 6 months from September, which would have been March, because the last test date would have been January. So you're only going to get 3 to 4 months use of them if they're not issued until September, because that January date is going to be 12 months from the last test date.
Okay. Our next question is again around that. They would like to know, is it cheaper to purchase new gloves than do an annual test?
I don't want to get into specific pricing, but in our experience, the cost of testing, including shipping back and forth to a qualified test facility, is still less expensive than purchasing new gloves. For example, we see Class 0 gloves out in the marketplace at $50 a pair and up, and that's for low voltage gloves, where to test that pair of gloves, even with round trip freight, is going to be less than half that. So that's going to be the user's decision, but why throw them away?
Absolutely. All right. This question is it allowable to inspect your protectors and gloves in the morning, then store them assembled for quick access, then disassemble at the end of the day?
Absolutely. As long as you're inspecting them at the beginning of that workday, yes, you can put them together and have them ready for when you need them. And then at the end of the workday, my recommendation is disassemble them, let them dry, let them recover at the end of the day overnight, and then repeat the process the following day. But yes, you don't have to stop to put the protector on over the rubber glove as soon as you're going into the job if you do that at the beginning of the workday.
Okay, perfect. What additional PPE is used or needed for arc flash and industrial electrical safety, and does Saf-T-Gard carry those items?
Second question is easy. That's yes. The first question is it's going to depend on an arc flash hazard analysis, which will determine if 8 cal daily wear is enough, an arc flash face shield, or a complete hood or a complete coverall. So there's no easy answer to the first part of that question. It's going to depend on what that arc flash hazard analysis is of the particular facility.
Okay. Can you recertify new gloves that are older than 1 year?
Yes, the gloves can be recertified with a complete visual inspection and electrical test, and then that clock starts ticking from the date of that recertification. If gloves are taken care of, stored properly, used properly, they can last for years. When we have visitors take a tour of the Voltgard Test facility here in Northbrook, Illinois, and that question comes up, well, how long do the gloves last? I will pull out and show gloves that I know were manufactured in the late 70s and early 80s and still look good and will pass an electrical test every day.
That's pretty cool. All right.
However, just to be sure, tongue in cheek, if you walk on them with golf shoes, they're not safe anymore.
Of course, yeah, for sure. So that looks like it's it for questions for right now. So while we wait to see if anybody has any more lingering questions, Richard, Ben, I want to throw it back to you. Is there anything that you want our audience to take away from today to keep top of mind so that they can be safe and successful in their glove journey?
Well, from my perspective, and I guess I appreciate the opportunity to present this and speak for the last 45 or 50 minutes. But we always know that at the end of a program like this, there's going to be the questions that are, oh, I wish I asked this. Well, on the screen now is our contact information for Ben and for myself. We are, glad to provide consultation recommendations, get you in touch with some very, very qualified people who can visit your facility and perform that arc flash analysis. And then once you have that report, then we can step in with the proper protective apparel and rubber insulating products to meet the needs that are defined in that analysis. There's no simple answer to the arc flash protective clothing question, but when it comes down to the shock hazard, that's pretty easy. We know what the voltage application and exposure is. We can recommend the rubber insulating products for that. Ben, let me throw it over to you. Anything else that you want to add?
I just would add a couple things. Just recently, we started adding a low voltage size 6 to our offerings. So we do now go from 6 to 12, and I believe our friends at Salisbury go from 7 to 13. So you now have between the companies a full offering size range of 6 through 13. And the other thing I wanted to throw out there is that gloves come in different colors for the purpose of testing, like Richard has been talking about. That way, someone is wearing, the guys are equipped with black gloves from January through June. They go back in for testing, and then the yellow gloves, let's say, are used from July through December. That way you can tell if someone is still wearing black in September, they have not rotated their gloves back. So that's why you do see gloves made in different colors. It has nothing to do with class or application or anything like that. It's all about testing and rotation.
And that color rotation is an essential element that I neglected to mention, thank you, Ben, of the Voltgard changeout program, where we'll exchange those gloves and then we'll hold them for the next time they need to be exchanged. And some of the largest companies in our customer portfolio work exactly the way Ben just indicated, of using one color for half the year and another color for the other half of the year.
Okay. Well, again, that looks like it's it for questions. So Richard, Ben, you did a really good job of going through everything today to make sure that there wasn't a ton of questions and people feel settled and good with the information that you gave. But I want to reiterate, Richard and Ben's contact information is on the screen right now. Take that down, reach out, ask those questions. We say it all the time, there are no stupid questions when it comes to safety. We'd rather hear the question 100 times than not at all. So make sure you are jotting down that question, those contact information, and asking those questions. Reach out to your team. We want you to stay safe. Richard, Ben, a huge shout out to you for being here for today, for lending us your knowledge. We always appreciate keeping us safe in the workplace. So thank you, not only to you, but Saf-T-Gard and PIP Global Safety, because without you guys, we don't know which direction to go. And of course, I want to thank everybody in attendance today, because without you guys, none of this would be possible. So thanks again. Take care, stay safe, and make sure that you are keeping those hands safe. Take care, everyone.